The year was 1942. Across the skies of Europe, a strange new predator was appearing, sleek, deadly, and unlike anything Allied pilots had seen before. Reports were coming in from stunned Spitfire squadrons over the English Channel. British pilots spoke of German fighters that seemed to dive faster, climb harder, and twist away with impossible agility. They called it the Butcher Bird. Its official name was the Focke-Wulf 190, and soon it would terrify even the best Allied aces. At first, few believed the reports. The Royal Air Force had spent years perfecting the Spitfire, the pride of Britain, agile, beautiful, and battle-tested. Yet now, men who had faced the Luftwaffe since the Battle of Britain were returning shaken, describing an enemy aircraft that outclimbed, outrolled, and outgunned them. In the summer of 1941, it had appeared suddenly over France, its radial engines snarling like thunder, its guns shredding through Spitfire formations before disappearing into clouds. The Air Ministry dismissed some of these accounts as exaggeration, combat confusion, until one grim day in August, when a Spitfire MKV squadron from Tangmere tangled with a flight of FW-190s near Dieppe. For Spitfires went down within minutes. The survivors returned home, barely believing what had happened. It could turn inside us, climb away, and accelerate faster, one pilot wrote. It was like fighting something from the future. For the RAF, that comment wasn't just frustration. It was a warning. The Luftwaffe had a new weapon, one that threatened to erase the Allies' advantage in the air. But what was it exactly? No one outside Germany had seen one up close. Intelligence officers gathered scraps of information, reconnaissance photos, combat reports, the occasional piece of wreckage from crash sites. They pieced together vague outlines of a fighter that looked bulky yet performed with shocking grace. In truth, the FW-190 was the brainchild of a quiet engineer named Kurt Tank, a man whose name would become legend among aircraft designers. Tank believed that a fighter should be as rugged as it was fast. Unlike the Messerschmitt Bf 109, which favored a slender, inline engine, Tank designed the FW-190 around a massive BMW 801 radial engine, a choice that shocked even his colleagues. Many thought a radial engine couldn't provide the sleek aerodynamics needed for a high-performance fighter. But Tank had a secret. He designed the plane so precisely that the airflow wrapped cleanly around the engine's broad nose. The result was a machine that combined brute force with delicate precision, a warbird that looked heavy but flew like lightning. The Allies began to feel the consequences almost immediately. Luftwaffe pilots, many of them veterans, now dominated the mid-altitude fights over occupied France. British squadrons lost men faster than they could be replaced. It became clear that without understanding this mysterious fighter, the Allies couldn't hope to beat it. But how could they study an aircraft no one had captured intact? Fate, however, was about to intervene. In the spring of 1942, deep over the French coast, a Luftwaffe pilot named Armin Faber took off in his FW-190A-3 from a base near Brest. The day's mission was routine: intercept RAF bombers, engage their escorts, and return home. But in the chaos of aerial combat, Faber made a fatal navigational error. Chased by Spitfires and disoriented in haze, he mistook the Bristol Channel for the English Channel. Instead of heading south toward France, he flew north, directly into British airspace. What happened next has become one of the most famous accidents of the war. After a brief dogfight near the Welsh coast, Faber, low on fuel and confused, spotted an airfield below and decided to land, believing it to be a Luftwaffe base in France. But it wasn't. It was RAF Pembrey. To the astonishment of ground crews, a German fighter, pristine, armed, and intact, came in for a perfect landing on a British runway. The FW-190 rolled to a stop. Faber climbed out, pistol drawn, expecting to be greeted by German comrades. Instead, he was met by British soldiers aiming rifles. One of the most advanced fighters of the war had just fallen, undamaged, into Allied hands. When the news reached London, disbelief turned into excitement. For months, British intelligence had dreamed of capturing one of these aircraft intact. Now, by pure accident, they had won. The Air Ministry immediately ordered the FW-190 flown to Farnborough for testing. Engineers and pilots gathered around the plane like archaeologists unearthing an alien artifact. Its thick wings, squat stance, and brutal simplicity seemed to defy every design principle they knew. But the real shock would come once they climbed inside the cockpit. The Spitfire pilots who had faced the FW-190 in combat always said it felt alive, that its reactions were instantaneous, its power endless. The engineers at Farnborough were about to discover why. As they opened the canopy and peered into the cockpit, they found something astonishing. The layout was unlike anything they had seen in British or American aircraft. Everything was logical, streamlined, built for the pilot's hands and instincts. Switches were positioned exactly where they were needed, not scattered across panels like in the Spitfire. Instruments were grouped by function, controls simplified for speed. Even the seat adjustment system felt futuristic. It wasn't just a fighter, it was a machine designed around human efficiency. When Allied test pilot Captain Eric Winkle Brown, one of the most skilled aviators of the war, took the captured FW-190 for its first test flight, he realized within seconds that this wasn't just another enemy aircraft. The controls felt different, balanced, smooth, perfectly responsive. The engine, powerful yet manageable, gave the plane an almost unnatural thrust. It was the finest handling fighter of the war, he would later say. But what the Allies were about to learn from the single plane would ripple across the entire air war. The FW-190 wasn't merely faster, it was smarter. Its design philosophy challenged everything the RAF and USAF thought they knew about fighter ergonomics, power management, and pilot survivability. What they discovered inside that cockpit, from its automated engine controls to its simplified flight systems, would astonish even the most experienced engineers. It was as if the Germans had designed a fighter not just to win battles, but to make the pilot part of the machine itself. And for the Allies, understanding it was more than curiosity. It was survival, because if they couldn't match it, the skies of Europe might soon belong entirely to the Luftwaffe. When the captured Focke-Wulf 190 arrived at the Royal Aircraft Establishment in Farnborough, the atmosphere was electric. Word had spread that Britain finally had won a fully functional FW-190. Mechanics, engineers, and pilots crowded around it, studying every line and rivet of the aircraft that haunted their skies for nearly a year. It was immediately clear that this machine was something different. The aircraft surfaces were smooth, tight, and meticulously fitted. The wing design was thick yet efficient, optimized for high-speed maneuvering. The RAF engineers were accustomed to British craftsmanship, elegant, yes, but often overcomplicated. The German fighter, by contrast, felt brutally efficient. Every feature had a reason, every system had a purpose. When test pilot Eric Winkle Brown prepared for his first flight in the captured FW-190, he studied the cockpit layout. At first glance, it looked foreign. Rows of German markings, strange instruments, and a broad control column instead of the slim spade grip he knew from the Spitfire. But then he realized something surprising. Everything made sense. The throttle, propeller pitch, and mixture controls were consolidated into a single lever. That meant one motion could adjust the entire power system. In the Spitfire or Hurricane, the pilot had to manage 3 separate levers while fighting, a process that demanded constant attention. But in the FW-190, automation did the work. The aircraft's BMW 801 engine had a mechanical Kommandogerät, or command device, that automatically adjusted fuel mixture, propeller pitch, and boost pressure in real time. To an Allied pilot, this was science fiction. Brown would later describe it as astonishingly simple to operate. The pilot could focus entirely on combat, instead of juggling the engine controls, an advantage that could mean the difference between life and death in a dogfight. The Germans had built not just a powerful machine, but a pilot's weapon, something designed to reduce mental workload in the chaos of battle. Even the canopy design shocked the British engineers. The FW-190 used a wide, blown canopy that offered almost 360-degree visibility, a stark contrast to the narrow view of the Spitfire. From the cockpit, the pilot could see behind him without twisting his neck or straining over the fuselage. The seat was higher, the cockpit spacious, the dials large and easy to read. It was a war machine built with empathy, engineered for the human inside it. The flight controls were equally revolutionary. Allied fighters tended to have light, sometimes twitchy control responses, excellent for turning fights, but unstable at high speed. The FW-190, however, retained perfect balance across a vast speed range. Its wide-track landing gear gave it superb stability on takeoff and landing, something Spitfire pilots envied, and its roll rate was unmatched. In testing, the FW-190 could roll nearly twice as fast as any Allied fighter of its time. That roll rate wasn't just a statistic. It was a killer advantage. In combat, it allowed German pilots to evade attacks instantly or switch direction during dogfights before their opponents could react. It turned aerial duels into deadly games of reflex. Allied pilots who faced the FW-190 often said it could disappear in a roll. 1 second it was in their sights, the next it was gone. Then came the power. When Brown advanced the throttle on his first takeoff, the 1,700 horsepower BMW 801 came alive with a deep, thunderous growl. The aircraft accelerated effortlessly. In climb tests, the FW-190 outperformed the Spitfire MKV by hundreds of feet per minute. Its broad wings gave it superb low-altitude control, and its air-cooled engine meant it could take damage and keep running. Unlike the Spitfire's delicate liquid-cooled Merlin, the British engineers began to realize that this wasn't just a better fighter. It was an entirely different philosophy of design. Where Allied aircraft focused on elegance and aerodynamic purity, the Germans had prioritized pilot survivability, battlefield efficiency, and simplicity under stress. Everywhere they looked, they found evidence of that philosophy. The electrical systems were modular and easy to replace. The fuselage panels could be removed quickly for maintenance. Even the ammunition feeds to the machine guns were cleverly arranged to prevent jamming. The aircraft had self-sealing fuel tanks, armor plating around the cockpit, and redundant hydraulic lines, all designed to keep the pilot alive even after taking hits. And yet, despite its ruggedness, it flew with grace. Brown's flight reports described it as light, responsive, and astonishingly stable. He noted that it could dive faster than any Allied plane without shaking apart. The thick, short wings produce incredible lift, but remain strong under immense stress. When he returned from his first flight, the engineers crowded around, eager to hear his impressions. Brown's first words were simple: "Gentlemen, we have been underestimating our enemy." Soon more test flights followed. Performance trials confirmed that the FW-190A-3 could outclimb and outroll the Spitfire MKV in nearly every category. Only at extreme altitudes did the Spitfire regain an advantage, but by then, the Luftwaffe was already planning high-altitude variants. The shock spread through the Air Ministry. Britain's finest fighter was now second best. The intelligence reports from Farnborough reached as far as the United States. American engineers studying the results realized that the FW-190's innovations could not be ignored. Its systems inspired elements in future Allied fighters: simplified power management, improved cockpit ergonomics, and bubble canopies that would appear on the P-51D Mustang and late-war Spitfires. Perhaps most impressive of all was how adaptable the FW-190 was. The Germans had designed it with modularity in mind. It could be transformed from a nimble interceptor into a ground attack aircraft by swapping out wings, weapons, and armor panels. Within months, the same airframe was carrying bombs, rockets, and cannons, becoming a multi-role monster that terrified troops on ground as much as pilots in the air. For the Allied test teams, this versatility was as frightening as it was brilliant. Here was a machine that could change roles faster than their production lines could adapt. It was an industrial masterpiece, built under wartime pressure, yet executed with surgical precision. But there was something else the British discovered, something that almost no one outside the Luftwaffe had understood. The FW-190 wasn't designed for Germany's elite aces alone. Its systems made it easier to fly for average pilots, too. The automation, the clear layout, the stability, all of it reduced training time and improved combat readiness. It was, in every sense, the perfect soldier's fighter. As the tests continued, one conclusion became impossible to ignore. The FW-190 had set a new standard, not just for speed or power, but for what a fighter could be. And the Allies, for all their technological achievements, were playing catch-up. Every pilot who flew the captured FW-190 came down from the cockpit with the same expression, all mixed with unease. They all knew what it meant. Somewhere over Europe, hundreds of German pilots were sitting in machines just like this, waiting. But what the Allies learned from this captured bird would not go to waste. The data gathered at Farnborough would directly influence the evolution of Allied fighters, pushing designers to create faster, simpler, and more efficient aircraft. Still, the question lingered. How had Germany managed to leap so far ahead so early in the war? And how could the Allies close that gap before it was too late? Because the skies of Europe were still in flames, and the lessons hidden within the FW-190 were only beginning to be understood. By late 1942, the British test pilots had logged dozens of hours in the captured FW-190. Every flight brought new revelations and a growing sense of urgency. Reports were sent daily to the Air Ministry, and behind closed doors, Allied designers pored over the data, desperate to understand what made the German machine so formidable. What they uncovered changed everything. The FW-190 wasn't just a fighter, it was a philosophy written in metal. It proved that a warplane didn't have to be delicate to be fast, or complex to be advanced. It showed that pilot-centered design could turn even average airmen into deadly opponents. And most of all, it forced the Allies to confront a truth they quietly ignored. The Luftwaffe wasn't just relying on daring pilots. It was out-engineering them. At Farnborough, Eric Brown continued to push the FW-190's limits. He dove at the speeds few Allied fighters could safely reach, rolled it through violent maneuvers, and tested its acceleration at combat power. The more he flew it, the more one thought haunted him. If the Germans had fielded this aircraft earlier, the Battle of Britain might have ended very differently. By the end of 1942, the RAF was already working on countermeasures. The Spitfire Mk9, an emergency upgrade powered by the new Merlin 61 engine, was rushed into service. It wasn't originally part of production plan, but the appearance of the FW-190 had changed the game overnight. The Mk9 could finally challenge the Butcher Bird on near equal terms. In many ways, the British owed its creation to the very aircraft that had terrified them. Meanwhile, in the United States, designers at North American Aviation were paying close attention. They studied the FW-190's reports and noticed its cockpit ergonomics and pilot-focused layout. Those ideas began to influence the evolution of the P-51 Mustang, particularly its later variants. The iconic bubble canopy that gave Mustang pilots their panoramic vision, that concept echoed the lessons learned from the German fighter sitting in a hangar at Farnborough. As the war dragged on, the FW-190 itself evolved. Germany introduced the F and G variants, ground attack monsters with armor plating and heavy ordnance. Later, the D9 Dora variant appeared with a long, sleek nose and a liquid-cooled inline engine. It was faster, climbed higher, and fought toe-to-toe with the very best Allied planes until the final months of the war. For Allied pilots, seeing a door on their tail meant one thing. They were in serious trouble. But as the tide of war turned, the FW-190's story took a darker turn. The machine that once dominated the skies was now outnumbered, its pilots dwindling, its fuel scarce. Germany's industry, bombed relentlessly, struggled to produce enough parts. The Luftwaffe that had once ruled Europe's airspace was slowly suffocating. Yet even in its final days, the FW-190 remained a symbol of defiance, rugged, lethal, and elegant in its brutality. Back in Britain, the engineers at Farnborough continued their study long after the initial excitement faded. They dismantled the aircraft piece by piece, documenting every cable, every hydraulic line, every hidden trick of its construction. What they discovered wasn't just brilliance, it was practicality. The FW-190 had been built with mass production in mind. Panels were interchangeable, components accessible. Where the Spitfire required artisans, the FW-190 could be built by assembly line workers. That realization startled the Allied analysts more than anything else. Germany, despite fighting on multiple fronts, had found a way to design a fighter that was both high-performance and easy to manufacture. In modern terms, it was a difference between a handcrafted sports car and a perfectly engineered race machine built for war. As Eric Brown later recalled, the FW-190 was not beautiful in the way the Spitfire was, but in function, it was the most superb fighting machine of its era. Those words would echo for decades. What the Allies learned from that single captured plane shaped the next generation of air combat. By late 1943 and into 1944, Allied fighters began adopting many of its lessons. Simplified engine controls, improved cockpit ergonomics, all-round visibility, and pilot-friendly instrumentation became the new standard. Even the ruggedness of the FW-190 influenced the design philosophy of later aircraft like the Hawker Tempest, the Grumman Hellcat, and the P-47 Thunderbolt. It's a strange twist of fate. A German fighter accidentally landed on a British runway, helping shape the aircraft that would one day defeat it. But the FW-190's influence didn't stop with the war. After 1945, captured examples were flown by Allied nations for years, studied by engineers who would go on to design the first generation of jet fighters. Its layout, the central focus on pilot comfort and control, directly influenced post-war aircraft design philosophies around the world. In a way, every modern fighter cockpit owes a small debt to Kurt Tank's masterpiece. And what of Tank himself? After the war, the man behind the FW-190 escaped capture and went on to work in Argentina and later India, where his engineering mind continued to shape aviation projects for decades. Yet he always carried pride for the Butcher Bird, the aircraft that for a time gave Germany control of the skies and earned respect from its enemies. In 1945, as Allied troops advanced into Germany, they found the shattered remnants of FW-190 production lines, rows of unfinished fuselages waiting for engines that would never come. But the machine's legend endured. Pilots who had faced it never forgot its scream, its ferocity, or the sheer shock of realizing how far ahead it had been. Looking back, it's almost poetic. The FW-190 began as a secret, emerged as a terror, and ended as a teacher. It forced its enemies to evolve, and in doing so, ensured its own legacy would never die. When Eric Brown last spoke publicly about the aircraft in his later years, he smiled and said, "The FW-190 taught us humility. We thought we had the best, and then we flew theirs." Even decades later, aviation historians still point to that moment, the day a German fighter mistakenly landed in Britain, as one of the most valuable captures of the Second World War. That single event compressed years of research and handed the Allies a blueprint for survival. It was more than just luck. It was a turning point, a moment when one man's navigational mistake gave the free world the knowledge it needed to fight back. In the end, the FW-190 was more than a machine of war. It was a glimpse into the future, a preview of where aviation was heading. Fast, efficient, pilot-centered, and brutally effective. It was a masterpiece born from war, destined to influence peace. As the sun set over the wrecked airfields of Europe in 1945, one could imagine that somewhere in the distance, a lone FW-190 still roared across the clouds, its engine echoing through time, a reminder of the day the Allies looked into the cockpit of their enemy and realized just how close they had come to losing the sky.